So I ended up doing internship in Cochin Shipyard in 1997. 20 years old boy along with his friends visiting Cochin Shipyard and seeing the massive infrastructure that is built in Cochin Shipyard for the shipbuilding, ship repair and docking facilities and so on and so forth. They took us to a place called dry docking. That's the first time in my life I'm actually visually seeing something of that magnitude. We used to design all those fancy islands of those days like Palm Island, the World Island and so on. 4% of our GDP is coming from the blue economy. And we believe very strongly that there is a huge potential to be explored, that the government of India has actually already set a target of doubling up this into 8 or even 2 digit in the subsequent stage of our GDP from only blue economy I'm talking about. Let's shift the gear to science part. Exciting science, to be honest with you. In fact, I learned a lot during my engineering profession time about the science, and I used to wonder why I did not choose science. To be honest with you.
Namaskar and welcome to another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. As we like to think, this is your future simplified. This podcast is brought to you by IITM Global, an initiative of the Office of Global Engagement at IIT Madras. IITM Global is our platform to help take our research, our education, our startup portfolio, our thinking and philosophy broadly to the global audience. Learn more about what IITM Global does and how you can partner with IITM Global through the link in the description below. The topic for today's conversation will be about our oceans. As we all know, we grow up reading in books. 70% of our planet is covered in water. It's not an overstatement to say that look around and you will see some object around you that would have been on a ship. Shipping for logistics, shipping for the country's defense, and broadly everything about ocean technology is going to be a big quote-unquote wave of the future. To learn more about that wave of the future, I have the absolute privilege of hosting Professor Balaji Ramakrishnan, the Director of the National Institute of Ocean Technology and a professor at IIT Bombay, to tell us a little bit about this very exciting engineering, technology and even science space. Balaji, welcome to the podcast and thank you for making the time.
Thank you for inviting me to have a wonderful conversation with you all.
The pleasure is all mine. Let's start with your own academic journey. You've been associated with ocean engineering for a very long time. Where did this start? You were in a civil engineering program. So let's start with your undergrad training and then...
Well, thank you so much for hosting me, and I'm very happy to address the audience. I hope our discussions are going to take interesting future for the next generation engineers and scientists from this country. First of all, I would like to tell you that I'm basically an undergraduate civil engineer.
Okay.
So it so happened that I was so keen. This is under the Maritime University, and I graduated from. And then at the beginning of final year, we wanted to do something slightly different, and it was 1997. I'm talking about, so around 20 years of my age, and I wanted to do some kind of internship. So I ended up doing internship in Cochin Shipyard.
Okay.
This was in 1997. 20 years old boy along with his friends visiting Cochin Shipyard and seeing the massive infrastructure that is built in Cochin Shipyard for the shipbuilding, ship repair and docking facilities and so on and so forth. Amazing facility.
Yeah.
And it was like a wow moment for all of us. I was accompanied by my friends, and we spent about a month of internship at Cochin Shipyard. I must thank Cochin Shipyard for that. 15 days we spent in the, they call it as maintenance department. I think we understand how the dredging activities are happening, how they maintain the marine infrastructure of the port within the port premises and so on. Then next 15 days, they put us in the design section. That was really an eye-opener for us. And in one of those days of our internship, they took us to a place called dry docking. That's the first time in my life I'm actually visually seeing something of that magnitude. So the engineer took us down. It was a dry dock. It's a dock basically, having a door, very large door that stops the water entering into the dock. It's a massive structure. I'm talking about 20 meter tall, so like 60 meter wide to 100 meter length and things like that. It's a massive well type of dock. So he asked me to go butt my back behind the door and just imagine 20 meters of water column is behind you, and this door is just preventing the water to entering into the dock. It was a moment that I really cherished the engineering that I have chosen as my career.
Yeah.
First thing. And then we came back to our office back again to the Cochin Shipyard design section. They asked us some kind of assignment to be done as part of our internship. So they asked us to design this dock, which is too much to ask for a 20-year-old engineer. I mean, yet to be becoming an engineer of that kind. But then we took a lot of books from the library. We took a lot of the national as well as international standards, codes. And we spent next 15 days in designing a sketchy information of a dock. And I got to learn a lot of new things. Those were never taught in our standard BTech civil engineering curriculum, after all. Only port and harbor, these couple of, probably the words that I would have heard during my entire 3 years of my civil engineering time. Otherwise, absolutely nothing. That really motivated me to come to ocean engineering. This may be the reason why I landed up in this position right now. Then I came to IIT Madras immediately after passing out of my undergraduation. I became a project associate in the civil engineering department, and this is the path that I used to walk every single day. From civil engineering department to the Valacheri gate, and every time I cross, I get to see the ocean engineering center. At that time, it was only a center, not even a department. Then I used to wonder, what these guys are doing when the civil engineering department and what ocean engineering guys are doing. I randomly used to enter the department, and I was just a project staff in the Department of Civil Engineering, and got to know there are a lot of facilities, interesting facility. You must be knowing IIT Madras has got. And then I thought, okay. So
I think they had a wave basin even back then, right?
Yes, that's actually built at least 40 years ago.
Yeah.
So I think I entered and started looking at, going around randomly, of course. These are all, of course, may not be known to anybody now. So I used to walk around, what are these facilities and what for this? And I started, those days I think internet facilities are not much familiar like we do now. And then I got to interact with the students who are coming out of the building. Maybe I met them in the tea shops, maybe in the canteen. I think those days it used to be a small canteen out there.
Yeah.
And used to meet them, chat with them. I got to know more. And I decided, if at all I had to do something, I have to do it in this department. That was my determination. Went back home, wrote GATE examination, cleared, joined master's program in the same very department. And then of course I did a lot of interesting experimental research as part of my master's first. And thanks to my professor, I think, who encouraged me to do PhD, I continue to do my PhD as well.
Who did you work with here?
Professor Vallam Sundar is was my supervisor, and I must thank him. He's such a wonderful person that he not only supervised the PhD, I think he allowed us to explore new things. I think that's something I really like of him very personally, that he has given us the opportunity. I mean, of course, he has thrown these opportunities to everyone, not just only to me as an individual. He has thrown everyone. I think those who have taken it, very seriously, probably, they have learned a lot. And he allowed us to work in his R&D projects. He allowed us even to work in industrial projects. And that's where I got to know there is a huge gap between what you study in a standard curriculum and textbooks and what is being realized in the practice. There is a gap between these two. So I wanted to fill those gaps. And then immediately after my PhD, in fact, between my master's and PhD is another very interesting story I must share with you. Since I was decided to kind of continue from master's to PhD continuously, my supervisors insisted me that, why don't you continue this same research problem so that you can quickly finish your PhD and so on. I said, nothing doing anything. I must take something very challenging myself. They cautioned me, warned me a lot. In spite of that, I think they allowed me again to go ahead. It took something very challenging, and that probably got me two interesting accolades. One, my master's thesis was awarded as the best graduate thesis work by American Society of Mechanical Engineers.
Wow.
Yeah, and then my PhD, because I chose to do something else, is awarded by Ministry of Shipping, Government of India, one of the best PhD thesis work. So I think immediately after that, I decided to, usually people ask, what are you going to do after your PhD, right? So the question was posed to me as well. I told them that I wanted to become a faculty of IIT. one of the IITs. That was very determined, decision at that point of time. Then immediately after my PhD, I told my boss that I think I'm going to industry. But you said you wanted to come back to IITs. I think it's not matching well. Usually people prefer after your PhD you go to postdoc or you work with any R&D institutions or academic institutions. Then that's the usual way route to come back to IITs. But again, I took challenge that I wanted to expose myself to industrial practices of how this ocean engineering works really. With a great amount of caution again from all my well-wishers, I took this decision. Went on to work with the consulting industry in the Middle East for about 4.5 years.
Okay.
It's a French consulting company, but we used to design all those fancy islands of those days like Palm Island, the World Island and so on. You might have heard all of this.
Yeah.
So some of these islands were also, kind of designed by us, our team. We involved right from the beginning, engineering investigation to all the way up to the supervision of the construction activity and all that. We took up a lot of challenging projects, not just only the Gulf country, but also the entire Middle East, all the North African as well as even the African countries as well. Then, like I decided, I came back to IIT Bombay as professor. I continue to do my research activities even during my professional services. And that probably fetched me to come back to IIT Bombay as faculty member. I started an MTech program there in ocean engineering specialization and still successfully running in IIT. And of course, now I'm on deputation by the Government of India as director, NIOT, in front of you now.
Wonderful. I think India doesn't have many undergrad ocean engineering programs, but there are a lot of master's level programs. Tell us a little bit about what is taught in a master's program in ocean engineering. And how is it different from civil engineering, let us say?
The natural environment, I think that makes the difference. For example, if you are a civil engineer, probably you'll be good in constructing infrastructure. It could be even a major infrastructure on the land topography part. But when it comes to ocean, there are a lot of dynamics that is not being taught in the undergrads. Okay, for example, civil engineering. We strongly believe that there are some specialized courses that will allow and pave way for you to understand the dynamics of the ocean first in place, and then probably you'll start designing the infrastructure later on. So I'm speaking only from the engineering perspective. There are a lot of amount of science as well, again, equal counterpart on the other side, similar to your biology and chemistry and physics. We have equal verbatim in our ocean environment as well. Oceanography, physical oceanography, chemical oceanography, biological oceanography, and these are very specific subjects. Because there are, again, the dynamics controls, their ecosystem is also going to be different. So this is the reason why we strongly believe that there must be some basic fundamental, undergraduations like it could be anything. It could be civil engineering. Sometimes people prefer to take the mechanical engineering as their undergraduate, and then they went on to do offshore engineering in the subsequent stages, master's programs and so on. Or even it could be electrical engineer and then they went on to do underwater autonomous systems, robotics and things like that. In my opinion, I think it may be okay to begin with the master's levels where one would like to specialize in the subject of their expertise and so on. And I strongly believe that ocean engineering is the best, probably the master's program that accepts almost all the bachelor's discipline. There are some programs, again, in IIT Madras, I understand that they even accept masters with mechanical engineering background for their master's program.
Sure.
And bachelor's with mechanical engineering, and then they can also do master's program and so on. And same is the case with even BTech with naval architecture. They can probably do masters in ocean engineering and so on. At the master's level in the MTech ocean engineering program, if you speak from IIT Bombay perspective, we allow the students to understand the ocean environment first. That's the basic program. What are waves and how they are actually different from the conventional forces that they study in the land-based structures, and what are tides, what are the consequences of the water level being increasing and decreasing due to the astronomical information, what are cyclones, storms, even tsunamis, and all of this, unless they understand clearly, they will not be able to do a good engineering out there in practice. So that's the idea. So we expose them in the beginning, and then we slowly use the civil engineering or mechanical engineering background to build their actually engineering point of view, and how to build a port, how to build an offshore structure, how to build even a subsea pipeline, all of this in a complex structure. Then we started teaching them in the subsequent later stage. That's how we do.
Wonderful. I think it's a different flavor of engineering that is not very popular, and so I want to really make sure our audience gets a feel for that flavor of engineering. So in ocean engineering, so the graduates of ocean engineering are obviously very important for the country because there is a lot riding on everything oceans. Let's talk about the the potential for ocean engineering in a country, for a country like India. We talk of shipping, we talk of offshore exploration, oil and gas, mineral exploration. Tell us a little bit about all of these potential possibilities where tomorrow's jobs can be created.
Sure. I think one thing that I forgot to tell in the beginning itself, that even before we ask question why ocean engineering, the first question should be why ocean.
Why ocean? Huh?
Yeah. So I think engineering comes later on. The involvement of the human is the one that brings engineering. Otherwise, why ocean is very important actually for all of us to understand. There are two reasons I think I usually mention in almost all the audience and forum. One strong reason is that every second breath that you take in this world is coming from ocean. In case if you think that the trees that we planted and the tree plantation drive that we do is the one that brings oxygen, you please stand corrected. Every second breath that every single human being of this globe is taking the oxygen from ocean.
Yeah.
Bottom line, I think we should thank, if not worship, the ocean every day for our existence. The second point, another interesting point, is the day-to-day weather that you enjoy when you walk out of this room and the long-term climatic conditions. These two are completely controlled 100% by the oceans, not by the land mass that we are all living in.
Yeah.
So for these two reasons, even if somebody is living in a landlocked country, I don't have any ocean surroundings, so I don't have to thank, they should stand corrected.
Yeah.
For oxygen and for the very weather condition that is prevailing, even if it is a landlocked country. So for this two reasons, good reasons, every human being should thank the oceans. And this, I think, pays the bottom line, the foundation for all of us to actually cherish the surrounding of the oceans that helps us. Secondly, right from the humankind evolution process, we always lived along the waterline, the so-called water resources.
Either a river or a sea coast.
This is another bottom line.
Correct.
I think if you look at the human evolution, the population, over the time grown in this entire, set of planets that we have defined, that I think we have grown from those water masses. And we recently, all the so-called, the latest time that, we started using a term called blue economy.
Yes.
So the blue economy right now, the country like us, the maritime nation like us, 4% of our GDP is coming from the blue economy. And we believe very strongly that there is a huge potential to be explored, that the government of India has actually already set a target of doubling up this into 8 or even 2 digit in the subsequent stage of our GDP from only blue economy I'm talking about. When you speak about blue economy, we are just speaking about the living as well as the non-living resources of the marine environment.
Okay.
So this is actually a very broad classification, and maybe we can discuss about the living as well as non-living. Under the living resources, if you look at, we are talking about fisheries, and then all the, and we also classify that, how we can actually tap the blue economy potential into, some kind of stages. We talk about food, we talk about water, and when we speak about the energy, and then health. When we speak health, it is not just only the human health, vice versa, that we also should take care of the ocean. So ocean health is also involved in that. So
yes.
It is win-win situation. You take care of the ocean and the ocean takes care of you, and things like that. So the health is very common term, but we always use the ocean health as well as human health. And then the climate change that is being controlled by the oceans. So these 5 parameters that we actually keep it in our mind. So huge amount of food comes from the ocean. And we also can actually derive huge amount of potable water, with the growing population, shortage of the, the water resources, we can actually harness the potential of the ocean, where we can get the entire water being desalinated and then use it for the potable purposes. Third, energy. Energy is actually abundant. Massive quantum of energy in the various forms. And only we just don't know yet how to tap this.
This is wave energy or tidal.
Not just only wave, we are talking about tidal energy, offshore wind farms, and we are also talking about salinity gradient energy. Where the river meets open ocean, there are 2 different salinity gradient. One is fresh water and another one is 30 ppt, we call it as salt water. So using the gradient, the difference in the salinity, we can still generate electricity. And very interestingly, there is a project run by me in NIOT Bombay. It's happening as we speak. And we are trying to develop a small scale pilot prototype power generation from the salinity gradient of the order of 1000 watts to begin with.
It's like a little battery basically. Very interesting.
So we can actually generate electricity from the salinity
Sure.
gradient. And tidal currents is another interesting subject we would like to work and expand in future as well. That these are the in and out of the tides, every single other day due to the astronomical features like sun and moon celestial bodies. They attract the ocean waters, and then because of the the gravity, and then the formation of the high tide and low tide forms every day. These tidal energy is irrespective of the season. There is no season that controls the magnitude. So round the clock, 365 days, 24/7, the tides will always be there.
And very predictable.
Very predictive. That's the most important parameter. Unlike the wind, unlike the wave, the tide is the most predictive feature, a physical parameter in the globe. And once you know where are the locations, you can tap this energy. And because of the highs and lows of the water level, there is current. I'm talking about water current.
Yeah.
A flow of mass of water, and there are water particles actually get excited, and those can be also converted into electricity very well. And NIOT, the institute which I'm heading now, has already demonstrated a small scale power generation facility in Andaman Islands using the tidal current alone.
Wow. So this blue economy that you're talking about, right, has all of these elements. We'll come to the living blue economy a little later. Let's talk of the non-living blue economy. You talked of energy already. Then there is oil and gas and minerals. What are the potential, what are the prospects there? What are some ideas that are being explored there?
Well, I think, like I said before, over the millions of years of time, there are some natural formation of the polymetallic nodules in the deep oceans. And these are like stones. They look a lot like stones, but they have got actually huge amount of minerals built in. They are abundant actually, not only in the Indian Ocean but also in Atlantics and Pacifics. So once if you are able to bring them onto the shore, you can actually extract nickel, cobalt, manganese, and then there are a lot of other minerals which may be interesting to the futuristic material definition. I'm talking about batteries. I think batteries are now the talk of the day in the entire globe as we speak.
Sure.
We're talking about batteries, battery powered car, vehicle, mobile, and everything. I think some of these minerals and metals may even be helping us in designing the new age batteries as well. These materials are actually available abundant as well. And as you said already, NIOT again has explored. There are locations within our Bay of Bengal and Arabian Sea. There are some locations where we have gas hydrates. These gas hydrates are again natural formation of highly flammable materials. Basically, they are very resourceful material. There are some theoretical estimate that says that if you are able to tap through engineering means, that probably the gas hydrates available in the Indian waters may supply the fuel for next 100 years or something like that.
Wow.
This is theoretical estimate. Of course, people may be sometimes over exaggerating based on the fact. But I think we have identified there are some gas hydrates that are actually found on the seabed, but in the water depth of 1,000 meters or so. But how to tap this? The gas hydrates, since it's a natural formation, it requires a right amount of hydraulic pressure and right amount of temperature. If these two, even if one fails to exist, the material ceases to exist. So how to bring them to the ship up on the surface of the ocean and then back to your place on the mainland is still engineering challenge. So I see huge potential there. Youngsters, if they come up with a kind of through a hackathon or whatever it is, they come up with a solution that how to tap these hydrates, and it can be converted into any form. If you convert it to some other energy form, bring up to this shore or vessel, ship or something like that, it is wonderful. But right now we only have identified, and we are not even able to bring even a small pieces of that above. Maybe a sample can be brought out with a huge difficulty, but not to any industrial scale level. This is another non-living resource I'm talking about. Oil and gas. I think India has already started exploring the Andaman Seas. I happen to be part of one of the vessels that explores the potential of the oil in the Andaman Seas. We are on board of that. In fact, I was on board of the vessel. It's a massive vessel that is being brought from elsewhere to explore, drill a hole. I think on the day that we visited, the ship was actually drilling 5 kilometers deep from the seabed level below.
Wow.
And that particular day, they breached the 5,000 meters and they were celebrating. So I'm talking about, the kind of equipment, the vessel, specialized vessel, the system they brought in, the drilling tools, capping tools. All of these are actually very unique technologies.
Clearly, very, ocean engineering is very sophisticated and it's all pervasive. Now, for careers in this discipline, there is all of the potential that you described. Plus, let's talk a little bit about shipbuilding. So, where is India in shipbuilding? What is the future direction for that?
Well, I think, we discussed before, I think the shipbuilding industry is something that we should really scale it up. I think, in my personal opinion, we are really doing wonderful and doing great. But I think it's not just enough. The way that we want this industry has to pick up, build number of ships that we want, both for the commercial as well as strategic purposes, and even R&D purposes. In fact, institutions like ours, we banking on the research vessels of our own. We have sensors to be tested, sensors to be demonstrated, technology to be demonstrated. All of this happens actually in the middle of the ocean. So we need a dedicated vessel. And probably the commercial vessels or any other vessels cannot cater to the requirement of our institutions like ours. So we need specialized equipment, specialized handling system, specialized even the control as well as instrumentation system, because we are going to do some kind of R&D demonstration out there.
Yeah.
So there are a lot many parameters that we would be observing all the time during the demonstration period. So we build usually the R&D vessels. I think we have a huge demand of R&D vessels within our ministry I'm talking about, and we also have for the commercial vessels. And of course, you must be knowing the strategic purposes. We also build ships for the Navy and other Coast Guard and so on. Right now, we are doing good. And in my opinion, I think all the shipyards are actually handful of projects, I think, for the next few years, if not a decade. And obviously, we have huge demand out for the country as a whole, and we need to probably build more and more shipyards in the east as well as west coast of India. This is my personal opinion. But there's a huge potential for sure, yes.
And so among the, when we go back to energy, you said offshore wind. That's another possibility that we discussed a little while ago. Tell us a little bit about what we are doing in offshore wind and what is the potential there.
Well, compared to land-based, the windmills that we are talking about, wind farms, wind turbines, the advantage of actually going out in the offshore is that it's a continuous flow of wind, number one. Irrespective of season, I think we are able to tap more energy than on the mainland. I think the mainland, you would be knowing there are only specific locations where we can tap this wind energy. And similarly, I think there are some locations have already been identified by Ministry of New and Renewable Energy. I think another standalone ministry or sister ministry that works on estimating resource assessment of how much is wind power potential in the offshore environment. But when it comes to tapping of this energy, there is a technological intervention required. You need not only the right turbine, but you also need the right substructure that supports the turbine.
Okay.
So in the mainland, I think it's very simple. You bring a turbine, you bring a mast, you anchor it with a foundation, simple as that. But when it goes to offshore environment, the depth decides what type of substructure it should be to support the turbine. And then as you go deeper, beyond 100 meters or so, for example, water depth in the offshore environment, then the challenges are even more than that, because you'll have 100 meters of water column, you have a lot of wave dynamics and other current dynamics and so on. So that makes the engineering totally different ball game altogether. And to be honest with you and also to the audience, that right now we are still in baby steps in terms of the engineering and probably the installation part I'm talking about. Even though the engineering might have grown enough actually within the country, but the implementation is another big challenge. So you need to fabricate the substructures in parts, mobilize them to place where you are supposed to install them, including the turbines. We are talking about turbines of bare minimum 100 meter diameter and beyond, 200 meters and things like that. So it's a massive.
So these are bigger than land-based turbines.
That's the idea, I think. So when you have more wind potential, you should bring more big turbines to tap. I'm talking about 5 megawatts and so on, and beyond that. So without which I think it is going to be economically not so feasible. So bigger is better. And obviously we need vessels that can take these huge turbines, and then you also need vessels that can take the substructure and install there. I think in the offshore environment it is even more challenging. You have to stay in a place first of all, and you have the waves and other dynamics are actually making your vessels which carries this always in the 6 degrees of freedom motion, right? So you need vessels of highly controlled to their dynamic positions in a way that it understands the waves and gives a feedback system that the ship stays almost as if you are standing on a mainland. So you can imagine now what amount of technology has to go in, even the designing of the ship itself, first of all.
Very actively controlled to be stable.
We call it as dynamic positioning system.
Sure.
So DP system. So those dynamic positioning system has to be really very effective, that I can confidently raise the substructure and then place it on the seabed and then install it properly. And then you will be installing the turbine and so on and so forth. So I think in our country it is yet to happen, but I think we started working on the assessment part in the first place. How much is the wind potential really? So right now NIOT is working with MNRE, one of the MNRE's institution here in Chennai. It's called NIWE, National Institute of Wind Energy. So NIWE has actually entrusted NIOT to develop a floating buoy leader, the laser based Doppler sensor to understand the wind profiling in the vertical column. So these buoys will be very specialized design, and we are going to fit a leader on top of that, and these will be deployed in the place where we would like to have a continuous measurement for about a calendar year, covering all the seasons, and you probably get the profile. I mean, at what height, what is the wind velocity, what is the turbulent intensity. For example, this in wind turbine industry is another parameter is very important, that you should understand what is the fluctuation in the wind speeds.
Yeah.
There is a mean speed with which probably the turbine will be actually producing power. There will be fluctuations that may be going into the design of the blade itself and also the entire substructure as well, because they will be undergoing some fatigue. I'm little high.
No, it's important we talk about these things.
Yeah.
I think
so. I think it is it's very important for us to understand the wind profile up to 300 meters in the atmospheric column, and these buoys are going to be designed by us. Completely indigenous design.
Okay, very good.
And when we talk about leader, we are good actually in terms of the buoy design. I mean, I'm talking about NIOT. We have done actually a number of meteorological and oceanographic buoys in the past 2 decades of time. But the one that we are working on right now is totally different from what we have been doing in the past 2 decades of time. Coming out of the comfort zone, coming out of the conventional way of actually designing this. The reason is that so far all our sensors require relatively less power supply. So these buoys are actually standalone units, and they'll be anchored in the middle of nowhere. They get only sunlight, they have some solar panel, battery and things like that. So very simple system. But LIDAR is a power hungry system.
Yeah.
Massive power hungry system. So you need to design the battery management system in first place. How am I going to design the battery such that the LIDAR will be functioning throughout the year and collect this wind profile? And these are all very heavy data I'm talking about. So it collects data at every few meters in the entire 300 meters of the atmospheric column. And you need to have some oceanographic parameters and so on. So where I'm actually trying to highlight is that the moment you take one single challenge like this, there's a lot of interesting engineering coming into picture. I have now started working on the battery technology. Now I know how to control the motion response as less as possible so that the LIDAR is not going to make any errors. How am I going to fit the LIDAR? How am I going to transfer the data to the mainland? These are all huge data, and I have small bandwidth through the satellite telecommunication system. So I have to work on the data management system, battery management system, even the buoy in place, actually this positioning system, and the LIDAR itself, the system. You have mechanical engineering contribution, electronics engineering contribution, electrical engineering contribution, instrumentation engineers, naval arc, because they are the one who designs the buoy for us, mooring design. A lot of engineers come together to design.
Not to mention computer science.
Too.
So clearly a very interdisciplinary field. I think
one single subject, it brings every engineering into picture.
Yeah.
One buoy which is going to be deployed with a LIDAR on top.
I want to do this one more time. This is so interesting. Let's take underwater robotics. Okay. I'm sure you can. The challenges in designing an underwater vehicle, and for some purpose, right? It could be ship inspection, hull inspection, or it could be just seabed inspection. Talk about what are some exciting ideas that you've seen from young men and women in startups in some cases, and then from big companies in other cases.
So in the underwater, I think NIOT would like to spend next at least a decade or two's effort, and also manpower, as well as the infrastructure investment in exploring underwater autonomous systems. So there are two ways of looking at it. I think one is what we call it as the remotely operated vehicles. In the relatively shallow water depths, up to the order of 500 to 700 meters, we prefer to operate something what we call it as the remotely operated vehicles, ROVs. NIOT has actually designed and patented. In fact, the technology is also transferred to the industries, and now they can also produce that in the commercial scale. Now we have transferred this technology to two different companies, and there is a bit tether, cable controlling this. So you keep like a joystick, and then you can control the movement of that, and you can also fit a number of sensors, scientific payloads, and like you said, the ship hull cleaning purposes, or even the underwater infrastructure inspections I'm talking about. This is another interesting engineering that I would like to highlight here. The underwater inspection is something that we wanted to build the capacity in the country. There are waters which are not always clear. Always. If you go to Gulf of Khambat, Gulf of Kutch, or Sundarbans, or even in some locations in the Bay of Bengal and Arabian Sea, the water will, I'm talking about ocean waters, will always be murkier. There are some locations which are so turbid that if you insert your hand up to the wrist level, you will not be able to see the edge of your finger. That's the kind of turbidity we are talking about. Highly murkier, that you will not be able to see. Even if you have spent like buying a highly sophisticated underwater camera, it will see nothing. So only some technologies can see, like 3D sonar system or something like that. The reason why I'm highlighting is that these places, if you do not even get to see what's there on the other side of the infrastructure, how will you get the assessment of the structure's condition? Sure. For example, if you are asked to do the conditional assessment of a offshore platform below the water, there is some damage or there's some kind of a marine growth, you wanted to get it cleaned up and so on. So that's exactly where the tethered, remotely operated vehicles that we use a lot. We can attach the payloads that you want, interested in, and so on. The moment you cross water depth beyond 700 meters and so on, and you wanted to really do survey, exploration purposes and all that, then only the autonomous systems actually come into picture. I think only autonomous system can actually be thriving or surveying in those places. We call it as autonomous underwater vehicles, AUVs. Majority of these underwater autonomous systems are expected to be intelligent as well. You may not be able to give instructions to these systems. Probably they should take the decisions on their own. And that's exactly where you have all the artificial intelligence, and it takes the decision on its own. If it come across obstacle in a large size, it decides on its own that it has to rise up and maybe take a detour, things like that. All of this is being done by the autonomous system. So if you look at one single AUV alone, the design part alone, it again brings huge amount of different disciplinaries of the engineering on board. First, to begin with naval architecture. See, it's supposed to design the body. It's not only the hydrodynamical shaped body, but also the flotation. These autonomous systems actually take a dive, and they can plunge and also come up. They have to come up. Once you've done the job and in the subsea conditions, you have to come up.
Correct.
So this controlled by the buoyancy, management of the buoyancy, management of the trim system, at what angle I'm supposed to take a dive, and so on and so forth. All of this is actually huge input, but we take it from the naval architect, number one, to begin with. Then you have the intelligence system, sensors, scientific payloads, imaging system, and then the decision making. Like before you said, I think the computer programming. The moment I see obstacle based on the sensor information, what am I supposed to do? What are the options available at my disposal to take a call? So these are all decided by it on its own. So we are working right now in our campus to design a full-scale underwater autonomous system. And we are talking about homing and docking. In the long run, NIOT, not only NIOT, I think the whole world is now started working on how to power these autonomous systems. Charge, for example, once they are done with their job and extend their mission and serviceability, how do we give the battery charged power supply below the water? So we are talking about docking system, homing system. Again, it has to find its home on its own. We cannot give instructions. I'll tell you one challenge. There are two challenges, of course, we are having below the water. One is communication. The moment you lift the ship, the underwater system, and it is actually diving, take a dive in the water depth of thousands of meters, then the only way that it can communicate to the mothership is through the sonar, sound effect. Okay, the sound system. So this is one thing. So it doesn't work with any of your so-called satellite or GPS and things like that. The second is navigation. Below the water, GPS doesn't work. I'm talking about way beyond 500 meters.
Sure.
I think there are some GPS, being validated up to some shallow water depths, like 50 to 100 meters, not more than that. So once you go below, none of your satellite can help. So you need to find your way out. And you should know, first of all, where you are. So all of this, what we call it as the inertial navigation system. It's another big science, in fact. Interesting science. Autonomous system should be in a position to understand where I am right now with respect to my mothership, or homing system, or maybe the docking system. It should find its way back.
Yeah.
So this is Very exciting science and engineering, I'm telling you.
Yeah, I think this obviously involves communication engineering. It involves, mechanical, electrical, and maybe even some chemical engineering for good measure. Tell us a little bit about, let's switch topics and talk about shipping. Like I started to say, it is not an exaggeration that something around you came on a ship to the room you are sitting in, right? There's so much logistics that is handled by shipping. And it is also one of the most energy efficient modes of moving goods and material. Where are we in terms of logistics? We talked of shipbuilding itself, but in terms of logistics, do we have enough capacity, or what can young men and women do if they are interested in that space?
Well, when it comes to transport over the waters and the shipping logistics in very specific, time matters a lot. So what is the turnaround time of a ship which is allowed to get into a port and then quickly finishes either the unloading of the cargo or loading of the cargo, and how quickly it gets out? So the time decides the efficiency of the port, and also time decides the cost. The more the time that you stay away from the port, even you get the permission to get into the port and unload and load the cargo, the cost of the commodity is going to be certainly shooting up. So the time is money, and shipping is very serious challenge that we always look at very critically. When you talk about the logistics, shipping logistics very specifically, the quicker you allow the ship get into the harbor, get it berthed or docked, quickly do the loading and unloading of your cargo, and all of this matters a lot. Now we slowly started moving autonomous systems that actually can handle the cargo part. Okay. So it can be quicker. There are some robotic cranes that already started actually appearing in the commercial scale, that they operate the vessels in a short period of time that can actually empty the ship. And once they empty it, I think usually they take some other cargo from that particular location. So you should also be in a position to keep the cargo and commodity ready to be loaded onto the vessel and then moving into the next port of call, and so on and so forth. There are a lot of interesting engineering started happening in the automation of the cargo handling, and also automation of the navigation aid of the vessel that would be getting into and out of the harbor system. In my opinion, I think there are a couple of ports have already started implementing the autonomous cargo handling system in our country very excitingly, and they are very successful in terms of doing that. But huge potential, in my opinion, still open for all other ports to adopt and all other engineers also to work on this subject.
So if somebody wants to get into developing that kind of technology, you would suggest they do an MTech in ocean engineering and sort of figure out a way to work for a company that does some of this engineering, or are there other pathways now?
Well, it is not necessary to be MTech ocean engineering all the time. So if somebody is having actually a master's background in mechanical engineering, or it could be even the automation engineering. There are automation engineering, automobile engineering also. I've seen people who are very keen, because these are all mobilizing the cargo in and out. Okay, so not only that, I think there are associated industry also flourish. When you talk about shipping industry, it always gives some kind of a feedback business to the moment the cargo comes and reaches the port. That's not the end destination.
Yeah.
It has to reach the hinterland.
Yeah.
So there are rail network, we have road network, and there are some dedicated cargo mobilizing transport system as well. I think there are dedicated corridors in India. I think you must be knowing. From Bombay to Delhi, you wanted to connect a dedicated corridor, and these tracks will not actually play any other train, except commodities. Dedicated, no passengers, nothing else.
Sure.
So there is a huge infrastructure also builds up the moment you start talking about shipping logistics. So, in my opinion, if somebody has the will to venture into the new subject like this, I think they can be from any engineering background, with a modest amount of understanding of what are the available information and what are the challenges that they'll be facing ahead, and so on.
Let's talk a little bit. You started to say that every second breath we take comes from the ocean. So the science of the oceans, how is it that the ocean is creating all this oxygen? How do we keep it this way for the next generation? And you also talked of how the climate is controlled largely by the oceans. So let's talk a little bit about ocean science and environment, as we call, right? Again, if somebody wants to go into ocean science understanding, what are the pathways that are available in India today, and what would a graduate there be doing in their career? Yeah,
this is a really interesting question. In fact, I think we are so far talking only about the engineering point of view. I think let's shift the gear to science part. Exciting science, to be honest with you. In fact, I learned a lot during my engineering profession time about the science. And I used to wonder why I did not choose science, to be honest with you.
Yeah.
There are some science which are so much exciting to me. Then I used to wonder, I should have taken this subject as my career.
Sure.
And it makes me really envy of the science that is really being explored, especially in the marine science I'm talking about.
Yeah.
There are two things, of course. One is the physical system as such. Like you asked, started with the oxygen part. The ocean is full of phytoplankton and zooplankton. Some are seen through naked eye and some cannot even be seen by our naked eye. Maybe you require a microscopic view of that. My science counterpart colleagues in NIOT used to tell me, you just take only one drop of ocean water, only one drop I'm talking about. You'll find millions of species in that.
Millions of species. Wow.
So that's the science I'm talking about. Very exciting range of microbes, bacteria, fungi, and so on. You may be wondering, what are these going to really be helping us? I'll tell you. We strongly believe, of course, all of us. Now I joined the science community in supporting their claim. For every single human disease right now that exists, there is a medicine from ocean. It's just that we don't know yet. There may be a microbe which may actually produce a medicine that may even cure the worst disease that you are talking about right now with the humankind. Just that we don't know yet how to extract this. I'll tell you one interesting fact. The known discovered species on the terrestrial environment, the land mass, is of the order of 8 to 9 million species that we have so far found out. It can be macro species to as micro as possible species. We call them as environment microbes and so on. 8 to 9 million species have been discovered so far. Whereas from the ocean, we have so far explored only 2 million species discovered. Look at the contrary. 70% of the globe is ocean. Only 2 million species found out so far. Only 30% of the land mass, we have found 8 to 9 million species on the terrestrial. That's because, you are so convenient. Why should I really risk my life in going to the open ocean to find out some microbe? Rather, I would actually, take a soil in the environment. I'll start actually exploring. So there are challenges, of course, in exploring the species from the open ocean.
Yeah.
Our team has already found out a couple of deep sea microbes. They have gone into the pharmaceutical industry already. And there are some which are very useful for your food color, dye, cosmetic. So all of these products that we have already produced. And transfer the technology also to the industry as well.
Very good.
One single microbe I'm talking about. Multiple usage, value-added products they're talking about. So there are very interesting science about species which live in the deeper oceans. When you go down in the open from the surface, the hydrostatic pressure plays a huge role. You must be knowing.
Yeah.
As an engineer, I know only every 10 meter I will have 1 bar increasing the pressure. Correct. Because of the hydrostatic pressure. So just imagine when you reach 5,000 meters of water depth, you will experience 500 bars of pressure. Yeah. Which is 500 kilogram per centimeter square. If I put it in the right perspective, your smallest fingernail in your hand is roughly 1 square centimeter. Just imagine on this 1 square centimeter, you transfer the entire load of the Maruti 800 car load or maybe some i20 Hyundai, something like that. What will happen to this finger? It will be crushed. That is a crushing pressure in the 5,000 meters of water depth. And human can never venture without any engineering support. You need to make a hull or like a Titan kind of very well protected submersible to enter into those with hugs and support and all that. Can you believe that there are some species which thrive in this 500 bar pressure? And they live happily there. And they exist very much as we speak. And there is one another interesting fact about the species, some of these species. There are 2 varieties of species. Now I'm talking about microbes. You may not be able to find out in the naked eye. There are some species which can be piezo tolerant, which means they can actually come along the water column even up to the surface and then go back. Piezo tolerant. They can adjust their body metabolism that they can actually take any amount of pressure, maybe some 100 bar to 500 bar, whatever it is. But there are some species, very interestingly, we call them as physophilic. They can only survive in that hyperbaric environment. They can't even survive when I bring it to this room. The moment I bring, of course you cannot even bring that first of all. Even if you manage to bring that and you open it up in this 1 atmospheric pressure, they will simply don't exist. They'll simply implode. These are all physophilic information. How they survive what makes them to survive out there is science. How to bring them to my laboratory to understand that better is science, engineering actually.
Correct. I think it's one of those disciplines also where the science feeds into the engineering, and the engineering, like you said, all these vehicles are highly engineered vehicles to do the science. So you need it's a good,
it's a very beautiful
virtuous cycle that is already set up in some ways.
Right now, NIOT is actually developing a sample collection system that brings these microbes, so-called the physophilic hyperbaric microbes. They will capture in the same pressure, same water temperature, because as you go down the 5,000 meters of water depth, you have the water temperature of the order of 1 degree or 2 degrees. So you have to seal them in the same pressure, same water temperature, bring them not only all the way to the ship and to the lab, but whatever the experiment that you would like to do with the microbe, it should be done in the same environment.
Right.
So we are making a lab out there in one of our campuses to accommodate all of this list.
Very interesting. Very, very interesting. We talked of how the ocean is responsible for climate as well. So let's talk a little bit about that connection. And climate change is happening, it's real. How are the oceans being affected by that? And how are the oceans in turn sort of affecting or feeding into the climate change process? Well,
like I said in the beginning, the entire climate as well as the day-to-day weather is actually controlled by the oceans, irrespective of where you are located in the global terrestrial mass. There are large amount of physical system that actually goes around the entire globe. For example, the water that melts actually from either Arctic or in Antarctic may even reach Chennai coastline. It may take only decades, maybe decades or even centuries, but eventually it will reach one day. So these are global circulations. We're talking about the underwater currents. The cold water comes from the North Pole and South Pole. They enter into the system, and then they also get warmed up, and then they actually go to the surface, and then they flow and things like that. When they come, they also bring huge amount of nutrient. This is science. So automatically all the life that are thriving in the marine environment may get this nutrient and so on and so forth. Secondly, and once you know there is a large circulation of these currents and flow of water happens, you need to understand it better to understand the today's weather condition and also to predict the tomorrow's weather conditions. These are going to be the crucial information. But how are you going to measure this? How are you going to the in situ information of what's happening below the ocean surface? How are this circulation system is happening? It's not just only the satellite which can see only the surface information. It's not just only the new mathematical modeling that you can use using the fundamental equations through your computer systems. But it has to be backed up with a huge amount of in situ observations, actual observation. That again demands a lot of technological development, engineering involvement. So we have devised some kind of underwater profiling system. These are all autonomous systems. You throw them, they look a lot like a spherical ball. You just throw them. It actually fitted with the patented, what we call it as buoyancy engine. It adjusts the buoyancy of its own so that the spherical thing can actually submerge on its own and reach even up to the water depth of 2,000, 3,000 meters. While going down, it collects all the important parameters like conductivity, temperature, and even the water depth profile and so on. And then once it surfaces, it will actually, through the satellite telemetry, it gives the data in real time. And these are drifters. Basically, they will drift along with the currents and so on. And it brings huge amount of science, the oceanographic science. But the development is purely engineering. I think the amalgamation of science and engineering in ocean is fantastic.
It's probably like very few other disciplines actually.
True.
Right? I think if you are on a commercial vehicle doing oil exploration, my guess is you may also have some scientists doing some science alongside that.
True.
Right?
True.
So in some sense, how would a young person now get into this? Let's spend the next 10 minutes talking about, like if somebody is doing, let's say, BTech civil engineering out there, what do you suggest as pathways for them to get into all of these exciting prospects?
Well, I think in my personal opinion, I strongly believe the fact that the bachelor degree curriculum that we have, not just only here throughout the globe, it basically gives you an overview of the engineering exposure, or for that matter, whatever the subject exposure.
Correct.
I also insist, at least as a well-wisher to those who are known to me, it is better you go little up in the ladder to do masters of your choice. I think that become now bare minimum, new normal now. I think with the bachelors, even I don't personally accept that you are master of something. So you get out of the bachelor's degree, and then you choose the topic of your choice. And now I think majority of the institutions, even including IITs, we started accepting the cross-disciplinary masters. I mean,
Correct.
somebody who has done bachelor's in civil engineering can even do masters in remote sensing or masters in mechanical engineering. There are some aerospace also I have seen, even if not in master's level, at least PhD. I have seen mechanical engineering working in climate science, mechanical engineering working in even large cycle circulation information. And similarly, I have seen, of course, civil engineer doing aerospace PhD. I know someone. The barrier is dissolving, in my opinion. The hardcore, I'm a civil engineer and I should be doing only civil engineering, nothing else on both sides. So those barriers, in my opinion, I think started dissolving long ago. That really a great opportunity for people to choose the career of their choice and their interests and their passion and so on. So if somebody has a will to do a lot of ocean engineering, science, related activity, I strongly believe that they can come from any undergraduate background. I know there are a lot of people. I know there is one man, I met him recently. He has done his BTech naval architect, went on to do, very interestingly, some coastal engineering subject for his masters, and then went on to do some kind of a climate science for his PhD.
Wow.
And I really liked him. He's not someone who has lost his way. He is someone who has found his way.
Right.
I think this is how I wanted to put it.
Very nice. And if somebody does, let's say, a master's in ocean engineering or master's in an allied discipline, but wants to get into ocean engineering, apart from labs like NIOT, maybe the National Institute of Oceanography in Goa, and a few other labs like this, which other organizations are sort of large employers of these kinds of graduates?
Well, there are some private agencies, even the insurance agencies, if you look at critically, they started actually hiring experts of subject domain. They need, of course, for example, when I venture into the ocean, I need insurance.
Yeah.
And that has to be evaluated by an expert. Only if you have in-house experts. And we started getting about shipping, we were talking about actually logistics actually in the marine environment, construction of the infrastructure. So unless you have experts in-house, these insurance companies probably may not be in a position to judge whether they can really go ahead or not. This is one side. So insurance companies now started hiring even engineers on board of their events. And finance institutions, they should know. And large institutions, also the chartered account institutions, they now started hiring specialized engineering experts in their domain. So this is one side. And now if you look at the maritime development along our being actually a maritime nation, the development is actually like exponential. We have some program run by Ministry of Shipping, like I'm talking about the Sagarmala, the coastal shipping. There is a huge opportunities actually for them to involve there. We have multiple institutions, individual ports, major ports, private ports, and then there are ports actually going to be built by joint venture by the public-private partnership and so on and so forth. It's happening as we speak. A lot of a scope for actually the maritime industry building itself, shipbuilding, port infrastructure development. The moment you're talking about shipping alone, there are a lot of amount of industry coming up. In my opinion, major infrastructure building companies are actually hiring specialized people even with the ocean engineering background. Offshore industry
as well, right?
And blue economy I'm talking about. I think we started developing some technology which will probably harness the resources. One single example I would like to tell you that as a nation, and the entire globe is also kind of committed, that we wanted to replace the fossil fuel in the aviation to begin with by 20% with the biofuels.
Yeah.
I think as a country, India committed to do that, I think by 2030 or something like that, which is very nearby I'm talking about. But where you get the bio resources? The land mass is already full of cities and the population spread along. Even if you use the agricultural product for your biofuel production, the land mass is actually of the order of around 3 million square kilometers. I'm talking about the land mass of the subcontinent. Sure. Look at the EEZ. Many may not be knowing. The water area that we have all the rights to explore is 2.4 million square kilometers of EEZ, exclusive economic zone for our country, which is of the order of our land mass. Very close, 2.4 million, and then you are talking about 3 million odd land mass. So if you can really do, I'm little exaggerating here, if you can really do agriculture in the open ocean.
Yeah. No, I think you are not exaggerating. C6 Energy is a company that is
Seaweed, exactly.
So you're
That's
not
what-
exaggerating. I think that's
Seaweed, if you can actually find a way, you identify locations and you start actually, cultivating seaweed, that can be a very good source for your biofuel. We are talking about 2.4 million. Not necessary that all of these EEZ should be used.
Yeah.
Even the locations which are conducive and supporting the seaweed growth, probably we should start exploring those.
sure.
For biofuel, one single topic perspective alone I'm talking about.
Sure.
It can be, I think we have some value added product from the seaweed, like you can produce fertilizer, fodder feeds and so on and so forth. A lot of value added product that you can bring out of the seaweed alone, one single product.
This is a very specialized discipline. If some student wants to find opportunities, what are the 2 or 3 large Indian conferences that a student can go to just to network and get to know more? Can you tell our viewers the places that you may go to make your presentation so they can also go there next time?
Well, I think from the engineering point of view, I have a well-known source that, just next door. Department of Ocean Engineering, IIT Madras conducts, I think, alternative years. I think once in 2 years they conduct international conference on ocean engineering.
Okay.
Where the entire domestic, experts, they come and gather, and where we have almost all the engineers working in the ocean related subject will gather.
Okay.
To best of my knowledge, academicians, R&D. I think they also managed to get some industrial participation as well. And the industry also slowly get to know that this conference happens on a regular basis, so people get to come here, and then that's a place for them to advertise or maybe even make their presence and so on. So this is one good example that I would like to promote. There are on regular basis, even NIOT institutions like ours, National Institute of Oceanography, there are some engineering based conferences and there are some science and engineering together. So INCHO is another event. It's called Indian National Conference for Harbour and Ocean Engineering. And there is one another organization called Ocean Society of India. There is one organization. It's a non-profit kind of organization that we are all kind of members. We promote the awareness. We also do outreach activities. We give awards for the best thesis and master's thesis and PhD thesis working in the allied area, science as well as engineering. So we promote this, and there are conferences also organized by OSI, Ocean Society of India, and so on. I think people have to be keep their eyes open for the opportunities. But these are something routine that happens. INCHO and ICO is something that appears in my mind immediately.
Wonderful. I think people need more of these networking opportunities in some way, so they can, somebody is interested, they know where to go. The last topic and last probably 1 or 2 questions on this, fishing. We said we'll come back to the living blue economy. What technology is today a fisherman able to use? And what are some problems that the fisherman is today encountering that a young man or woman listening can say, I will try and solve that problem? What is the technological foundation that is available already to our fishermen?
2 things, of course, I would like to highlight. One is that under our Ministry of Earth Sciences, MOES, we have multiple institutions, and we are basically the engineering institute in Chennai, NIOT. And there are some service-oriented institutions as well elsewhere. And one of our sister institution under MOES has developed what we call it as the potential fishing zone, PFZ.
Okay.
And this is actually a very successful model that we have adopted, and it percolated down the line to the last fisherman, I think, who is just going to go to the fishing immediately after a few minutes. So we have a very kind of interesting outreach and knowledge dissemination system. At the moment we wanted to inform all the fisher folks in a particular state, the message can go to their mobiles directly in their vernacular language, where they can go and find school of fishing available for them to fish. For this, we have worked a lot in the beginning. We are talking about information derived from the satellite. There are a number of mathematical tools that we run, and we also use the observation, in situ observation, backed up validation for all of our claims. So all this put together, now we come to a fair very interesting successful rate. Actually more than 90% of our potential fish zone definition is successful, and they can go exactly to these coordinates. We give also the coordinates. Fisher folks are actually extremely good in using the GPS. The moment you tell them the information, they know how to go, how to catch these fishes. And when we are talking about this PFZ, potential fishing zone, it's a large area I'm talking about. So it's not just only one fisher folk takes his boat and then comes back with the fish. There can be multiple villages can go together, and I think we also define what quantum, to some extent, what quantum of a fish could be there in that area and so on and so forth. This directly benefits the fisher folks.
Yeah.
Secondly, from the technological institution perspective, our institute has actually demonstrated very successfully what we call it as the open sea fish cage culture.
Open sea fish?
Cage culture.
Cage culture. Ah.
So you create a controlled environment where you can bring the fish larvae and then grow all the way up to the commercial scale. You can harvest after a few seconds. The reason why we developed this technology is that unlike the land-based aquaculture that we are talking about, mariculture we are talking about, this will allow the fish to grow faster. Our science and in fact our report and analysis said that the biomass growth, we are talking about the biomass growth for the given feed system, is 4 to 6 times larger than compared to the land-based fish culture we are talking about. The reason is that apart from the feed that you add, they also get the natural nutrient that is flowing in the open ocean. And we are talking about usually the relatively deeper oceans. I mean, to begin with, in the demonstrative scale, we have done it actually. We're still there in the Andaman Islands in the water depth of 20 meters. We put all these open sea fish cages with the mooring system designed by ours and the floating system designed by ours, net and all that. Even the feeder system, automatic fish feed system, it uses the natural, hydrostatic pressure. It feeds automatically at the time that you trigger. Not only that, our team has actually done a wonderful AI-based fish mass measurement system. So these are all fitted under the water. You get to see in your mobile that how much the fish has grown today. I mean, compared to. So you decide when to be cultivated.
This is a different scale of aquaculture.
Totally different scale. So there is a huge amount of science and engineering again. So if fisher folks are really voluntary, I think we closely work with the fisheries department in this particular project because they are our immediate stakeholder. I think it is going to be them who will be adopting this. So they now started coming back to us saying that, can you help us in designing this technology for the fisher folks? And there are 2 requests we have got it already, one from one of the maritime state along the east coast and one from the Andaman Islands, and we started getting a flooding of requests. Can you help us in designing these open sea fish catch cultures? So we are working on that.
Very nice. What are some problems that I think there are opportunities for startups to come and solve? Where are the greatest opportunities in this space for startups?
The underwater autonomous systems, I think it's still, in my opinion, it's evolving in our country, and a long way to go. And I strongly believe that the youngsters have already found that, and I could see huge enthusiastic, young students passing out of their masters, BTech. They approached us many times. Sir, can we use your facilities? Can we use your infrastructure? Can we use your resources? We have some ideas. We have some technologies. We help them out, including some of the startups come from IIT as well.
Sure.
And we also closely work with the systems like IIT, and we do some kind of hand-holding. There are some technologies that we have already developed, and we pass it to the industry, right industries, and we do hand-holding till the technological readiness level is reaching up to a level where they can actually start marketing.
Sure. We
usually stop at 5-6 tier level and transfer the technology to the industry. We do the hand holding for next couple of years, and they bring it to a marketable scale in the period. And we do that, of course. It's a time that's really happening as we speak. Exciting.
Clearly, a very fascinating field. Your closing thoughts. What is your short pitch to students as to why they should come into this discipline?
Not just only this discipline, maybe I'll make it more generic. I think they should be ready to take challenges. I think they should make it like a habit rather than run by the conventional way of thinking. I think they should come out of the the comfort zone, customize the things that are built around them, break the walls, come out, take your own challenges, and then you can even dream big, split it into parts. One at a time approach. I think nothing is impossible in the way that I think the youngsters are thinking these days.
There is only so much engineering you can do in an AC room, right? You really have to step out into the field and do the hard engineering, and that's what you will be proud of at the end of the day also. And I think ocean engineering seems to be one such discipline where you can leave a lasting impact. Professor Balaji Ramakrishnan, thank you so much for helping us understand this very complicated space. I think they should have ideally been 2 separate recordings. The science and the technology are so rich in topics that we should be discussing. I certainly hope we can do a part 2 at some later point of time.
Sure.
Thank you.
Sure. I'm very happy to share that actually. Thank you so much for your time and effort.
Oh, my pleasure.
I appreciate it.
My pleasure. This is another episode of the Professor Mahesh Podcast, your resource to help you make informed career decisions. I hope you picked up all of the excitement that is abuzz due to the blue economy growth that we foresee here in India, and how all of you can be participants and enablers of that growth. So come, learn of how you can be part of this exciting space and make informed career decisions. Wherever you go, make sure you completely understand what you're getting into. Until we meet again, be well, do good, and keep in touch. Goodbye.